Hello students, in this video will I'm going to discuss some MCQ type problems based on the topic Fourier series. So let us start with this topic. So the very first problem based on this topic is which of the following is an even function of t? So here we want to check that which of the function is even function. So what is the definition of even function? A function is said to be even A function is said to be even if f of minus of x is equal to f of x. Is if your function is f of x, and if we replace x with minus of x, if again equal to the function itself, then we say that a function is even function. Or we can say that if we draw the graph of the function, if it is symmetric about ordinate axis, then we say that a function is even function. So let us consider the first function here. Our first function f of t is t square minus 4t. So if I replace here t with minus of t, then this is minus of t square minus 4 of minus of t. This is equal to t square plus 4t. So definitely this is not the even function. So if I consider the second one, say let g of t is equal to t cube minus 3t. Already here we can see the power of t is odd. So definitely this function is not an even function. But let us check here. G of minus t is minus t cube minus 3 of minus t. This is equal to minus t cube plus 3t. So basically it is minus of t cube minus 3t. So this is minus of gt. So basically this is the condition of odd function. If f of minus of x is equal to minus of f of x, that function is called odd function. So now let us check the third one. The third function is sine 2t and 5t. So let us suppose I am considering this function as ht is equal to sine of 2t plus 5t. Right? So if I replace here t with minus of t, so this is sine of 2 of minus t plus 5 of minus t. So this is again sine of minus 2t plus this is minus of 5t. And we know that sine of minus theta is equal to minus of sine theta, because in the fourth quadrant sine function is negative. So this is minus of sine 2t minus of 5t. So this is minus of sine 2t plus 5t. So again, this is equal to minus of the function. So it means that this is a function, odd function. Okay. Because sine is odd function, odd power of t. A polynomial with odd degree is also called a odd function. So now we let us move to our last function, fourth function. So definitely our fourth option is the correct one. But let us check here. Fourth function, our function is let it be kt. This is equal to sine square t plus cos 2t. Okay, so we know that even powered function is even function only, but let us check here. So this is sine of minus t, but it's whole square, and this is cos of 2 times minus of t. So this is minus of sine t whole square plus cos of minus 2t. And because in the fourth quadrant cos is positive and minus square is also positive, so this is sine square t, and this is cos of 2t, because cos of minus theta is equal to cos theta, and sine of minus theta is equal to minus of sine theta. So this is again equal to kt only. So this is the definition of even function. So what do we get from here? That the correct option is option 4 only, right? So this is the even function of t. Okay, so how do we check that a function is an even function? It means that with the help of this particular condition, we can check that a function is an even function or not. Okay, let us move to the second question. So given the periodic function f of x Its value is minus x in the interval minus pi to 0 and x in the interval 0 to pi, and it is a periodic function with period 2 pi. Means after every 2 pi period, like in this case, the length of the interval is 2 pi. So after this particular part, again, this function repeats itself, right? So we want to find out the value of the Fourier coefficient Bn in this case. Okay. So the first thing is whenever we get a function in the form of minus L to L form interval, then firstly we check that either your function is even function or odd function, right? So like in the last problem we have discussed, how do we check that a function is an even function or odd function? There are two ways. Either we can draw the graph of the function. Okay, so like in this case I can draw the graph of the function. So this is the origin. This side I'm considering minus pi to 0 and this is 0 to pi. So what is the function here? F of x is equal to minus of x. So minus of x means when x is equal to minus pi, then the value of f of x is pi, right? So it means that the value of y is positive. Somewhere here its value is pi. So it means that as I start increasing the value of x, the value of function start decreasing. Okay, so it means that the graph of the function is like this one is not defined at the point x equal to 0. Similarly, in the interval 0 to pi, we know that f of x equal to x is a straight line passes through the region. So basically, if we check the graph here, f of x equal to minus x, this is the line, and f of x is equal to x, this is the line. So it shows that your function is symmetric about ordinate axis. So it's clear that your function f of x is even function, right? But otherwise, we can check the condition also. So how do we check the condition? F of minus x. So this is equal to, I replace x with minus of x. Here interval is minus pi is less than minus x is less than 0 and its value is minus x in the interval 0 is less than minus of x is less than pi, right? To now this is equal to minus of minus x is x, and if I multiply throughout with negative sign, then the sign of inequality will change. So it is pi is greater than x is greater than 0, and here it is minus x. Again, sign of inequality will change. 0 is greater than x is greater than minus pi. So basically, this is 0 is less than x is less than pi, and this is minus pi is less than x is less than 0. So in the interval minus pi to 0, the value of the function is minus of x. In the interval minus pi to 0, the value of the function is minus x. And in the interval 0 to pi, the value of the function is x. So it shows that your function is even function. It shows that your function f of x is even function, right? And in case of even function, the value of the Fourier coefficient Bn is 0. Why? Because we know that the Fourier series of the function is given by a naught pi 2 plus summation an cos n pi x upon L in general form if we consider. Otherwise, in the interval minus pi to pi, its value is nx only. But let us consider its value is n pi x upon L plus bn sine n pi x upon L, right? Where the formula of A naught is 1 upon L integral minus L to L f of x dx, and the formula of an is 1 upon L integral minus L to L f of x into cos of n pi x upon L dx, and the formula for Bn is 1 upon L minus L to L f of x into sine of n pi x upon L dx, right? So in this case, we want to find out the value of the Fourier coefficient Bn. So what is the value of Bn here? Okay, Bn is this one. Okay, and your function f of x is even. Okay, so let us suppose I consider gx as f of x into sine of n pi x upon L. Right? We already know that sine is the odd function, f of x is the even function. So what is g of minus x? This is f of minus x into sine of minus of n pi x upon L. But f of x is even function, so this is f of x, but sine of minus theta is minus of sine n pi x upon n. So product of even and odd function is odd function. And if this function is odd, then the value of the integral minus L to L is 0. Okay, so because we have the identity of definite integral, let me add one more slide here. So because we have the property of the definite integral that minus a to a f of x dx is equal to 0 if f of x is odd function. That is, if f of minus x is equal to minus of f of x. And if it is even, then this is 2 times 0 to a f of x dx if your function is even function. F of minus of x is equal to f of x, right? So if we just look at this formula, then because this is an odd function, cosine is even, f of x is even, so product is also even and f of x is even. So what is the formula of a naught in this case? A naught will be equal to 2 upon L, 0 to L, f of x dx. And the formula for an is 2 upon L, 0 to L, f of x into cos of n pi x upon L dx. And the formula for Bn is value is 0. But in this particular question, we are interested to find out the value of Bn only. So what do we conclude from here? So the conclusion is the value of Bn is 0. Okay. So in this case, whenever your function is even or odd, so we can simply use this particular condition that if your function is even, if f of x is even function, then the value of the Fourier coefficient Bn is 0. And if your function f of x is odd, if your function is odd, then a naught and an, both of them are 0, right? So we simply use to remember this particular condition. So because in this case we have checked that our function is even, so we can directly conclude that the value of the Fourier coefficient Bn is 0. Okay. Okay, let us move to the next question. The next question is the period of the function cos 3x is. Okay, so we know that f of what is the period? What is the meaning of the period of the function? A function f of x is periodic with periodic with period t if f of x plus t is equal to f of x, and t is the smallest value for which the function repeat its value, right? So we need to find out the smallest value of t for which this condition hold true. So we know that cos theta plus 2 pi, cos of 2 pi plus theta is equal to cos theta because cosine function is a periodic function with period 2 pi. But we are interested to find out the period of cos 3x. So it means that cos 3x plus 2 pi, this is also equal to cos of 3x. Okay. But here our function is f of x equal to cos a. That means when we are giving any input here, so its value is 3 times this one. So if I consider f of x plus t, this is equal to cos of 3 times x plus t. So it means that cos of 3x plus 3t, right? So what value we should add so that it is equal to cos 3x? So it means we need to add 2 pi. So it means that what is the value of 3t? This is equal to 2 pi because this is equal to cos of 3x plus 2 pi. Okay, so it means that what is the value of t? T is 2 pi by 3. So it means that if I take 3 common, this is x plus 2 pi by 3. And this is again equal to cos 3x, which is equal to f of x. So what is the smallest value of t? So it implies that the smallest value of t is 2 pi by 3. So it means that what is the period of cos 3x? The period of cos 3x is 2 pi by 3, right? Okay, now let us move to the next question. Okay, so in this question, we are given the Fourier series of the function is given as its value is 0 in the interval minus pi to 0 and its value is x in the interval 0 to pi. And the Fourier series of the function is already given here. But with the help of this Fourier series, I want to deduce the value of this infinite series. Okay, so this is also one part of the Fourier series. That is, sometime after the Fourier series, we need to deduce some infinite series expansion also. So what does it mean? So in this case, we are given the Fourier series of the function as f of x equal to pi by 4 plus summation n varies from 1 to infinity cos n pi. So basically, the value of cos n pi is minus 1 raised to power n. Sometimes this type of question could also be asked that what is the value of cos n pi, right? Its value is minus 1 raised to the power n minus 1 upon pi n square time cos nx and 1 upon n into again minus 1 raised to power n time sine nx. This is the Fourier series of the function. So I am interested to find out the value of this infinite series, right? So here you can see here we have only odd power square, 1 square, 3 square, 5 square. So even power terms are missing here. So what I need to do, I need to put some value of x so that I can remove this cosine and sine function from here so that we left with only the constant term, right? So firstly I need to eliminate this one, but in such a way so that we left with square term only. And you can see here we have n square and here we have n. So definitely I want to make this term 0, right? Because from this particular term only we'll get n square. And from here I am expecting only odd power term. Let us firstly see what kind of term we are getting here. This is basically the coefficient of cosine x, so it is an. So what is an here? Minus 1 raised to power n minus 1 upon pi n square, right? So if I open this series, if I open this particular series, so what do we get here? If I put n equal to 1, so its value is minus 1 is minus 2 upon pi times 1 square. If I put 2, then its value is minus 1 square is 1, 1 minus 1 upon pi times 2 square. So automatically this is 0. So it means that when we put odd term, then we get square. But when we put even term, then its value is 0, right? So it means that this term will be 0. So what I need to do, it means that I can directly get the required series from this particular term only. The only thing I need to make cosine function as 1 and sine function as 0. So I need to choose a suitable value of x from this particular function so that cos is 1 and sine is 0. So for what value of x? Cos is 0 and sine is 1. So we know that cos 0 is equal to 1 and sine 0 is equal to 0. And this value also falls within the interval. But what we find out here 0 is a part of discontinuity. But here 0 is the point of discontinuity. Okay. And we know that in case of point is a part of discontinuity. So what is the value of f of 0? This is equal to the average value of the left and the right neighborhood of 0 average value. Okay. So what is f of 0 positive? It means it lies this interval. So it is f of x equal to x. So if I put 0, then its value is 0. And what is 0 from negative? It means that we are considering left neighborhood. In this particular case, its value is 0. So the value of the function at the point 0 is 0. So if I put it here, this particular equation star, so what do we get? So we are getting f of 0 equal to pi by 4 plus summation n varies from 1 to infinity minus 1 raised to power n minus 1 upon pi n square into 1 minus 0, right? So if I open this equation, so in the left hand side it is 0, in the right hand side it is pi by 4 plus. Here we have seen that we are getting only corresponding to odd value of n we are getting this term, but for even term its value is 0. So it means that this is minus 2 upon pi is common. So what kind of term we are getting here? 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, and so on, right? So we are taking rest of the term on the left hand side. Let me consider one more slide here. So it means that this minus pi by 4 taken on the left hand side and in the right hand side we have minus 2 by pi. It is minus 2 by pi times 1 upon 1 square, 1 upon 3 square, plus 1 upon 5 square, and so on. So this negative side can cancel out. If I take pi by 2 on the other side, then this is pi by 4 into pi by 2. This is equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, and so on. So its value is pi square by 8. Okay, so whenever the question is asked in this way, that where we need to deduce the infinite series, so firstly try to open this particular summation. Okay, so you will identify that which term you need to make it, which term is required from this particular series and which term we need to eliminate. Like in this case, we are having only linear power of n, but we are expecting the series containing even power. So it means that we need to make this term 0. Okay, so we need to make this term 0 and we need to make this cosine function 1. So what is the suitable value of x for which sine x is 0 and cos x is 1? So we will put x equal to 0, right? And from here we get the value of the infinite series as pi squared by 8. So what is the value? The value is pi squared by 8. So this is the correct answer. Okay, now let us proceed to the next question. Okay, sorry. So in this question, we are given a function f of x is sine square x, and we want to find out the value of the Fourier coefficient a. Okay, again the interval is minus pi to pi. So whenever interval is given in the form of minus pi to pi, the first thing is you need to check that your function is even or odd. But because we know that sine square x is an even function, but let us check here. F of minus x is equal to sine of minus x square. It is minus of sine x square. This is equal to sine square x. Obviously, this is equal to f of x. It means your function is even function. It means f of x is even. Okay. And also, what is the length of the interval? So we are assuming that the length of the interval is 2l, which is upper limit minus lower limit. So this is equal to 2 pi. So from here we get the value of L is pi. So what is the formula of the Fourier coefficient an? An is given by 1 upon L minus L to L f of x into cos of n pi x upon L dx. So we are considering the general formula. So because this function is an even function, and I told you product of two even function is an even function because f of x is even, cos is even, and in case of even function, there we have discussed in the beginning that in case of even function, the formula we get a naught and an those 0 and the value of an is 0. Okay, so it is 2 upon l we are getting here, right? So the formula of a naught is it will be 2 upon l 0 to l f of x into cos of n pi x upon l dx. But what is L? L is pi. So what is the formula of an? An is equal to 2 upon pi 0 to pi sine square x. This is your f of x and this is cos of n pi x upon pi. So it means pi and pi get cancelled. So here we have a product of two functions. One is sine square and another one is cos nx. Okay, but sine is a non-linear. So to evaluate this integral, firstly we need to convert it into linear form. So we are using here the trigonometric identity that cos 2 theta. This is equal to cos square theta minus sine square theta. It is 1 minus 2 times sine square theta and it is 2 times cos square theta minus 1. So in this case, second identity is applicable because I need to find out the value of sine square theta. So what is sine square theta? This is equal to 1 minus cos 2 theta upon 2. So we are using this identity here. This is 2 upon pi integral 0 to pi 1 minus cos 2x upon 2 into cos nx dx. So this 2 and 2 get cancelled out. So we can separate this integral as 0 to pi cos n x dx minus 1 upon pi 0 to pi. This is cos 2x into cos of nx dx. Right? So here integral of cos nx is sin nx upon n, the interval 0 to pi. And here we have 1 upon pi. I can multiply and divide by 2 because again the product of two cosine function is a non-linear function. So we need to convert it into linear. So we are using the property 2 cos A cos B. So 2 times cos A cos B. This is equal to cos A plus B plus cos of A minus B. So we are using this property here. So this is equal to integral 0 to pi cos of A plus B and plus 2x plus cos of n minus 2 of x dx. Now let's start one more slide here. So integrating the first part we have already integrated. So the value of an is 1 upon pi already here. So substituting upper limit, it is sine of n pi minus sine of 0 upon n, right? So for the first part, and here minus 1 upon pi is again integral of cos n plus 2 is sine of n plus 2x upon n plus 2 minus sine of plus sine of n minus 2 times x upon n minus 2. But now here the problem is n minus 2 is in the denominator, and in case of Fourier series our summation running from 1 to infinity. So it means that obviously it is not defined for n equal to 2, okay, with the limit 0 to pi. So if I substitute here, because sine n pi is 0, already we have discussed there the two identity that sine n pi is 0 and cos n pi is minus 1 raised to power n. So basically at this any integral multiple of pi, the value of sine is 0. So here again, if I substitute upper limit, sine of n plus 2 pi, because n is any positive integer, right? So if we add 2, then again its value is 0. And n minus 2 is also integer. It's an integral multiple of pi, the value of sine is also 0, and sine 0 is also 0. Right? So all the term is 0, so it means that the value of an is 0, but here n is not equal to 2. So what about a2? So now we need to calculate a2. So a2 is obtained in the formula we are replacing n equal to 2. So its value is 1 upon pi 0 to pi f of x into cos of 2x dx, right? In the formula of an, we are replacing here n equal to 2 to get the value of a2. So again, substituting the function here, function is sine square x into cos 2x dx. So now again, it is a non-linear and linear function, so we are simply using the identity which we have used in the last part. It is 1 minus cos 2x upon 2. So here basically it is 2 upon pi because it is an even function, right? So this 2 and 2 get cancel out time cos 2x dx. So again, if we open this integral, then this is 1 upon pi. First one is 0 to pi cos 2x dx. And in the second part, we are getting 0 to pi cos square of 2x dx, right? So here there are two way again we can use the identity of cos 2 theta, right? It is one of the way. Other one is we can also use one of the property of definite integral, that's 0 to 2a f of x is equal to 2 times 0 to a f of x dx if f of 2a minus x is equal to f of x. Now we know that cos of pi minus 2x is in the second quadrant, cosine is negative, but because of the scale it is positive, right? So let us use this property here. So its integral is sine 2x upon 2 with the limit 0 to pi for the first part. And here this can be written as 0 to pi by 2 times cos square of 2x dx. Okay, okay. Otherwise, we can use the because there is one more property we need to use here that integral. Uh, okay, just wait a moment. Let me rub this particular part. I'm using the same property here. Property is uh, cos square theta is equal to 1 plus cos 2 theta upon 2. Let us use this property here. So this is 0 to pi 1 plus cos 4x upon 4 dx, right? So this is equal to here if we substitute the limit, so its value is sine 2 pi upon 2 minus sine 0 is also 0, right? Upon 2. And here 1 upon 4 is taken outside. Integral of 1 is x and integral of cos 4x is sine of 4x upon 4 with the limit 0 to pi. Okay, so upon 2 here it's 1 upon 2, right? So if we substitute the upper limit and lower limit in this particular part, let me add one more slide here. So the value of En comes out to be 1 upon pi. So first part is 0 and here its value is minus. For substituting upper limit, this is pi by 2 because 1 by 2 is already there and sine 4 pi by 4 sine 4 pi by 8, right? Minus sine 0 by 8. Now sine integral multiple by 0, so this is also 0. So its value is 1 by pi into minus pi by 2. So pi and pi cancel out, its value comes out to be minus 1 by 2. So this is the value of A2. So basically what do we get? We get the value of En is 0 if n is not equal to 2 and its value is minus 1 by 2 if n is equal to 2. Okay. So it means that what is the correct answer? The correct answer is option C only, right? But you will find out here that this question is very tedious one. It's a very typical because here first I need to calculate En, then we find that it is 0, then we need to calculate A2 also, right? But there is another way to calculate the same thing, right? Because what is function here? Our function f of x is sine square x, right? What is the purpose of Fourier series? The purpose of Fourier series to express our function in the form of sine and cosine function, right? And if we convert it into linear form, then this is 1 minus cos 2x upon 2. So basically, this is 1 by 2 minus cos 2x upon 2. So this is already the representation of function in the form of Fourier series, right? If I compare it with a naught by 2 plus summation and varies from 1 to infinity en cos nx plus bn sin nx, right? Right. If I simply compare with this one, so what do we get? Here the constant term is a naught by 2, then a1 cos x, a2 cos 2x plus a3 cos 3x and so on, and b1 sin x plus b2 sin 2x and so on. So if I compare the like term, what do we get here? The value of E naught by 2, that is the constant term is equal to constant term. So the value of E naught is 1. And what is the value of En? If I compare here, the value of En is 0 for all values of n except n equal to 2. Because what is the value of A2? A2 is the coefficient of cos 2x. Its value is minus 1 by 2. Okay. And what is the value of B8? Bn is 0 because there is no sine term. Is that we are assuming the coefficient of sine and x is 0. Okay, so it means that with the help of this particular part, we can directly get the answer. So I have solved you to show you that what is the actual result. If we proceed in this way, then it is very tedious job to find out the value of the Fourier coefficient. But if your function is already given in the trigonometric form, in that case, if it can be expressed in a linear form in terms of sine and cosine, then we simply compare it with the Fourier series of the function. Comparing the like coefficient, we can get the value of the Fourier coefficient directly. So this is how we can get the answer. Okay, let us come to the next question. So basically, what is the answer of the previous part? The value of a n is 0 when n is not equal to 2. Its value is minus 1 by 2 when n is equal to 2. Okay, now let us move to the next one. So this time, the question is we are given function f of x equal to x minus x square, and we need to express it in the form of half raised size series in the interval 0 to 1, right? Okay, so what is the half raised? The half raised size series of the function f of x is given by f of x equal to summation n varies from 1 to infinity bn sine n pi x upon L. So what is L? L is simply we are assuming our interval in the form of 0 to L. So in this case, we are comparing the length of the interval with L, or I simply compare the upper limit with L. So what is L here? 1. So it means that what is the Fourier series? N varies from 1 to infinity Bn times sine of n pi x. Okay, so what is the value of Bn? So the formula Bn is given by 2 upon L, 0 to L, f of x sine of n pi x upon L dx. So here the value of L is 1. So this is 2 upon 1, 0 to 1, f of x into sine of n pi x dx. So in this case, our function is x minus x square. So let us solve this integral part. So let us see what do we get here. So here the value of Pn is 2 times 0 to 1 x minus x square into sine of n pi x. So here we are going to use the product rule. We have already discussed in the video of Fourier series that the formula of u and v, which is the special formula which we are using in Fourier series, because here one function is polynomial, another one is a trigonometric function. So the formula uv is uv1 minus u dash v1 v2 plus u double dash v2 v3 and so on. Here v1 means integral of v, v2 means integral of v1, and v3 is integral of v2 and so, right? So let us proceed here. So it is 2 times first function x minus x square as it is. Integral of sine is minus cos n pi x upon n pi u integral of v minus derivative of u. Derivative is 1 minus 2x. Integral of minus 1 upon n pi as it is. Integral of cos is sine of n pi x upon n pi plus derivative 1 minus 2x is minus 2, and 1 upon n square pi square as it is. Integral of sine is minus cos n pi x upon n pi. Again derivative of 2 is 0, so we stop our integration here with the limit 0 to 1. Okay, so if we substitute the limit 0 to 1, so 2 times minus 1 upon n pi here as it is. If I substitute upper limit 1, 1 minus 1 is 0. And if we substitute 0, this is again 0. Now come to the second term. Minus minus is plus 1 upon n square pi square. Right? Now if I put upper limit, 1 minus 2 is minus 1 times sine n pi. And when I substitute 0, then its value is 1 times sine of 0. And we know that sine and pi is 0. We have already discussed that the value of sine and pi is 0 and sine 0 is also 0, right? So it means that this term is 0, this term is also 0, right? So basically we left with only last term minus, minus, minus. So it is a minus 2 time and cube pi cube and cube pi cube time. When I substitute 1, its value is cos n pi. And when I substitute 0, its value is cos 0. So what is the value of Bn here? So we actually left with the value of Bn as 2 already outside. It is minus 2 upon n cube pi cube time cos n pi. This is minus 1 raised to power n. Cos 0 is 1. So this is minus 4 upon n cube pi cube minus 1 raised to power n minus 1 upon n cube pi cube. This is the value of Bn. So if we substitute this value in the Fourier series, so what is the Fourier series here? So the Fourier series is f of x, that is our function is x minus x square. This is equal to summation n varies from 1 to infinity Bn. Bn is minus 4 upon n cube pi cube minus 1 raised to power n minus 1 time sine of n pi x. Okay. So now if I open this equation, if I put n equal to 1, so because you can see minus 1 raised to power n minus 1. If n is odd, its value is minus 2 if n is odd. And if n is even, then its value is 0. Because for odd value, its value is minus 1, its value is minus 2. For even, its value is 1, 1 minus 1 is 0. So if I open this particular part, then this is equal to, so minus 4 into minus 2, 8 upon pi cube common. So 1 means 1 upon 1 cube sine pi x. When I put 2, it is 0. When I put 3, 1 upon 3 cube sine 3 pi x. Again, for even it is 0. 1 upon 5 cube time sine of 5 pi x and so on. So if I simply compare, here we have a linear, 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 and here we have a cubic. So the correct option is option A. Okay. So first thing is you need to simply use here the product rule, u into v, and when we substitute the limit, this term is 0. First term will be 0, 1 minus 1 is 0, 0 minus 0, and sine n pi is 0, sine 0 is 0. So basically we left with only one term, and here we have n cube. And from here only you can identify that the correct option is option A only, because in rest all these three terms there is only linear power of coefficients. But only here in this particular part we have a cubic power. So from here only you can conclude that the correct option is option A. Right? Okay, let us move to the next question. The next question is, uh, we need to find out the value of Fourier coefficient A naught here. And what is your function x sine x? So what is the formula of A naught? A naught is 1 upon L 0 to 2L C to C plus 2L, sorry, f of x dx. So what is the length of the interval here? 2L is equal to 2 pi. So the value of L is pi. So the formula is 1 upon pi 0 to 2 pi f of x dx. So we simply need to apply the product rule of the function x into sine x. So the same formula which we have used in our last question. So product rule u into v. So u is x. Integral of sine is minus cos x minus derivative of x is 1. Integral of minus cos x is minus sine x. Derivative 1 is 0, so it means we stop our integration here using integral u into v as uv1, u dash v2, and so on. U x, v1 means integral of sine x, We know that integral of sine x is minus of cos x, and integral of cos x is sine x. Okay, so this is 1 upon pi minus x cos x plus sine x. Now if we put upper limit and lower limit, 2 pi cos 2 pi sine 2 pi, and when we substitute 0, 0 into cos 0 is 0, and sine 0 is also 0. So this is 1 upon pi minus 2 pi, and cos even multiple of pi its value is 1. So answer comes out to be minus 2 pi by pi, that is minus 2. Okay, because cos and pi is minus 1 raised to power n. So what about cos 2 pi? Minus 1 square, its value is 1. Okay, so this is the value of the Fourier coefficient. Okay, let us move to the next one. Okay, so this time we are given a discontinuous function in the interval minus 2 to 2. So obviously the length of the interval is 4. So what is the length of the interval? Upper limit. This is the upper limit. This is the lower limit. Minus of minus 2. It's 4. So what is the value of L? 2. So what is the formula of Fourier coefficient A naught? 1 upon L minus L to L f of x dx. So 1 upon 2. Interval is minus 2 to 2 f of x dx. But this integral is because your function is discontinuous, so we need to split our integral as minus 2 to minus 1, minus 1 to 0, 0 to 1, and 1 to 2. So here we find out that in the interval minus 2 to 1, its value is 0, and in the interval 1 to 2, its value is also 0. So we left with only these two parts. So this is 1 upon 2 minus 1 to 0. The function is 1 plus x, and in the interval 0 to 1, its value is 1 minus x dx. So this is 1 upon 2 x plus x squared by 2 in the interval minus 1 to 0, x minus x squared by 2 in the interval 0 to 1. So this is 1 by 2, upper limit 0 plus 0, lower limit minus 1 plus minus 1 square by 2 plus upper limit 1 minus 1 by 2, lower limit 0. So this is 1 minus 1 by 2 plus 1 minus 1 by 2 is already 1 by 2. 1 by 2, 1 by 2 cancel out. Answer is 1 by 2. So the value of the Fourier coefficient is 1 by 2. Okay. So now let us move to the next question. At the point of discontinuity, the sum of the series is. We have already discussed that at the point of discontinuity. So what is the value of f of x? It is the average value of the left neighborhood as well as the right neighborhood of a point. So it means that the correct option is option B in this case. Okay, next one. So if the Fourier series of the function is this, converges uniformly in the interval this, then what is the value of 1 upon L minus L to L f of x whole square dx? Okay, so basically we are given f of x equal to a naught by 2 plus summation a n cos n pi x upon n plus b n sin n pi x upon n, right? And what is a naught, a n, and b n? They are the Fourier coefficient. Okay, so we know that the value of a naught is 1 upon L minus L to L f of x dx. The value of a n is 1 upon L minus L to L f of x into cos n pi x upon L dx, and the value of Bn is 1 upon L minus L to L f of x into sine of n pi x upon L dx. Now what we need here, we need f of x square. We need f of x square. So what is f of x square? It means if I multiply throughout with f of x. Sorry. So in this series, because if you see the option, we need a naught square, square of the term only, right? So it means that we need the relation with the Fourier coefficient. So I multiply throughout with a naught. So we get a naught by 2 f of x summation n varies from 1 to infinity an into f of x into cos n pi x upon n plus bn into f of x into sine of n pi x upon L. After that, we need to integrate it between the limit minus L to L. Integrate minus L to L. Integrate minus L to L. Because a dot an and bn are constant, so we are integrating the rest of the function. Now, if you see this formula, what is the value of minus L to L f of x dx? This is a naught into L. So its value is a naught by 2 into a naught into L. Similarly, this is an, and the value of this particular part is an into L. And similarly, the value of this integral part is equal to bn into L. So, so if we take L common throughout, then this is a naught square by 2 plus summation an square plus bn square. And if we divide L on the other side, it will give us 1 upon L minus L to L f of x whole square dx. This is equal to a naught square by 2 plus summation an square plus bn square. So you can see here the correct option is option D only. Okay, so in this case, of course, here it is bit logical question because we need the value of f of x square and we need the relation with the Fourier coefficient only. So we simply need to understand that because a naught, an and bn they can be they have a formula in term of f of integration of f of x with sine or cosine function only. So firstly, we simply multiply it with f of x and we integrate our function. We can get the desired result. Okay, so let us move on to the next question. Okay, the next question is the half-range Fourier cosine series of the function. Okay, so half-range Fourier cosine series. So half-range Fourier cosine series formula is a naught by 2 plus summation a n cos n pi x upon L. What is L? L is the length of the interval which is pi. So if L is pi, so it is cos nx. And what is the formula of a naught? 1 upon L, because here L is pi, 0 to L, that is 0 to pi f of x dx. But because this function is discontinuous, so I'm considering it as 0 to pi by 2 f of x dx plus pi by 2 to pi f of x dx. So this is equal to 1 upon pi integral 0 to pi by 2. The value of the function is x, and in the interval pi by 2 to pi, its value is pi minus x dx. So if we solve this integral, integral of x is x squared by 2 and integral of pi minus x is pi x minus x squared by 2 with the interval pi by 2 to pi. And here it is 0 to pi by 2. So this is 1 upon pi, this is pi squared by 4 to 1 by 2 and this is upper limit pi square minus pi square by 2 and lower limit pi square by 2 minus pi raised to the power 2 by 8. Sorry. This is 1 by pi square by 8 as it is. This is pi square by 2 minus pi square by 2 plus pi square by 8. This will get cancelled out. So 1 by pi into pi square by 4 because pi square by 8 plus pi square by 8 is pi square by 4. So its value comes out to be pi by 4. Although in the out of 4 option, 3 option having pi by 2 only. So it means that the first part is okay. So it means that this is not the correct option. But still we need to find out the value of AN. So again, for calculating the formula value of AN, we are considering AN is equal to 2 upon L 0 to L f of x into cos n x dx. That is 2 upon pi 0 to pi by 2 f of x into cos of nx dx and pi by 2 to pi f of x into cos of nx dx. So it is 2 upon pi 0 to pi by 2. So in the interval 0 to pi by 2 its value is x into cos of nx, and in the interval pi by 2 to pi its value is pi minus x into cos of nx dx. So here we apply the product rule. This is first function, this is second. First function integral of cos is sin nx upon n minus derivative of x. Integral of sin is minus cos nx upon n square with the interval 0 to pi by 2. And here first function integral of second sin nx upon n derivative of pi minus x. Integral of sin is minus cos nx upon n square with the interval pi by 2 to pi. So substituting the upper limit, so pi by 2 into n sine of n pi by 2 minus minus plus. Okay, so on substituting upper limit here, it is cos n pi by 2 upon n square minus on substituting lower limit 0 into something is 0 and here cos 0 is 1 at this side. On substituting upper limit pi minus pi is 0. On substituting lower limit this is pi by 2 n sine n pi by 2 minus minus minus. We have a negative sign 1 upon n square cos n pi minus cos n pi by 2. So if we open this bracket, this is pi by 2n sine n pi by 2 cos n pi by 2 upon n square minus 1 upon n square minus pi by 2n sine n pi by 2 minus 1 upon n square into minus 1 raised to power n because cos n pi is minus 1 raised to power n. Okay, and minus minus plus 1 upon n square cos n pi by 2. So sine and sine term get cancelled out. So this is equal to 2 upon pi. This is 2 times cos n pi by 2 upon n square and minus 1 upon n square common minus 1 raised to power n plus 1 upon n square, right? Okay, the question is if a constant c is okay, so in the last question, f of x is 2x minus x square in the interval 0 to 3. So we need to calculate a naught here. So we integrate our function 2x minus x square. Integral of x is x square by 2. Integral of x square is x cubed by 3 with the limit 0 to 3. We can integrate our function, substitute the limit, upper limit minus lower limit, answer comes out to be 0 only. Okay. Okay, the next question is if a constant c is expressed as a half-range sine series, then the coefficient of sine 7x is. Half-range sine series is f of x is equal to summation n varies from 1 to infinity bn sine of nx, right? So if I open this, then we have a b1 sine x plus b2 sine 2x, so on. So b7 sine 7x. So basically, I need the value of b7. So what is the bar formula of bn? 2 upon L. Sorry. 0 to pi f of x into sine nx dx. So what is n? N is 7. So 0 to pi f of x into sine of 7x dx. So 2 upon pi, 0 to pi. F of x is constant and sine of 7x. So what is the integral of sine 7? It is minus of cos 7x upon 7 with the limit 0 to pi. So this is minus 2c by 7 pi cos 7 pi minus cos 0. And we know that odd multiple of pi, if n is odd, its value is minus 1. So it is minus 2 upon 7 pi. Its value is minus 1 minus 1. So minus 2 into minus 2 is 4c by 7 pi. So the answer is option 4. Okay, the last question is if your function is periodic function with period 2, then at the point of discontinuity x equal to 1. So in this case, basically, our interval is minus 1 to 0 and 0 to 1. So in the interval minus 1 to 0, the value of the function is 1. And in the interval 0 to 1, its value is 2. Okay, it has a behavior like this. And we know that this is one of the period of the function. After this, again, function repeated the same way. Okay, so if I want to find out the value of the function at 1, at the point of discontinuity, the value of the function is the left neighborhood of a point plus the right neighborhood of a point divided by 2. But in this case, the right neighborhood of a point is same as the left neighborhood of a point minus 1. So in this case, what is the value of this? This is f of minus 1 positive upon 2. So what is the value of f of minus 1 right neighborhood? It is 1. And here it's the left neighborhood of 1 is value 2. So 2 plus 1 by 2 value is 3 by 2. Okay, so because your function is periodic, so if we want to find out the value at the end point, so at this particular point, its value is the right neighborhood of minus 1, that is this, and the left neighborhood of 1, that is this. Okay, so this is how we can calculate the value at the end point. I think during the recording, there is a problem here, so I'll just repeat what I have done in this question. So here we have calculated the value of A naught, which is comes out to be pi by 2. But when we calculate the value of an, first we apply the product rule. So after applying the product rule and substituting the limit, we come out to its value as 2 times cosine pi by 2 cosine pi by 2. This is 2 times, and with the minus of 1 upon n square minus 1 raised to the power n upon n square. If we combine this, this is minus 1 raised to power n plus 1 upon n square, right? Now, if I consider this particular function as an, so here we can divide it into two cases. If n is odd, if n is odd, we know that odd multiple of pi by 2 cos is 0. So it means that this term will be 0 for odd multiple of pi by 2, and minus 1 raised to power odd is also minus 1. So minus 1 plus 1 is 0. So it means that for odd value of n, an is 0. So this old term will be 0 for odd value of n. And for even value of n, it is 2m pi, 2 and 2 get cancel out, so it is cos m pi. And for even value of n, this becomes 1. 1 plus 1 is 2. So we can get the value of a to m. So basically, it shows that we'll get only even term in an, not the odd term. Even term means we'll get even cosine, cos 2x, cos 4x, cos 6x only. So it means that if we look at here, there are two terms. Here we have cos 2x, 4x, 6x, and here we have cos 2x, 6x, and 10x. So we need to see that either we need cos 4x or 6x also. So what can we do? So if we see here, here again we get minus 1 raised to power m minus 1. So it means that again if m is odd, then we get minus 2. If m is even, its value is 0. So it means that again we get only odd term. So if we check here, 1 square, 3 square, 5 square. So it means that here we get only odd term. It means that this is the correct answer in this case. Okay. So I'll try to include some different kind of problems based on Fourier series in this particular part. So if you still find out any doubt in any question, then you can post your query. I'll try to provide you the solution for the same. Right? Try this problem. All the best. Thank you.